Today we're going to add and subtract rational expressions, and then we're going to simplify some complex fractions at the end. I'll wait and come back and define complex fraction when we get there. Hopefully I won't forget like I usually do in class. Let's jump into some problems. We're going to start with a review of least common multiples. That's what LCM stands for. So if I have 25 and I have 20, now, you can probably look at that and tell me right away what the least common multiple is, but I'm going to break down how we could go about doing this. So typically for the least common multiple, with numbers, we just sort of start multiplying them and we look to see what's the first number that we run into that they both divide into. But with polynomials, that would get thoroughly unpleasant, and there's a better way to go about doing this. So instead, I like to break this down into prime factors. We don't necessarily have to go all the way down to prime, but I'll show you what I mean. So 25, we know, is most easily written as 5 times 5. And I thought of 5 right away because the 20 also has 5 as one of its factors. But 20 is 5 times 4. All right, now kind of like when we were learning to factor, we would identify what's their common factor. Well, when we're trying to identify a least common multiple, it actually really helps to identify their common factors first, because their least common multiple is always going to be built from their common factor and then each of the unique factors that also goes into the number. So the 5 that they have in common, I pull once. And then any stray factors, so the extra 5 from the 25 and the 4 from the 20, all have to go into the least common multiple. So 5 times 4 is 20, times 5 is 100. So their LCM is 100. That approach that I just took with the numbers, although it's not necessarily the most common approach that we take when we're finding least common multiples for numbers, it is analogous to the approach that we want to use when we're finding LCMs of polynomials. So let's take a look. If I break this down the same way, then the first thing I'm going to want to do is to factor each of these polynomials. So I've got two trinomials. Let's see, this looks like it could be x plus 6 times x minus 2. And then I take the second trinomial, x squared minus 6x plus 8. And I'm going to factor it. Well, I'm hoping it includes either an x plus 6 or an x minus 2. Probably not going to be an x plus 6 because 6 doesn't go into 8. So let me think about x minus 2. Well, it looks like I would have to multiply by an x minus 4, and sure enough, that works with the middle term. So when I look at this, I can see that these both have an x minus 2. So the LCM is going to contain that x minus 2 that they both have. But it's also going to contain the extra x plus 6 from the first trinomial and the extra x minus 4 from the second trinomial. The product of those three binomials is the least common multiple. Now, I don't necessarily need to multiply that out all the way, so I'm going to go ahead and leave it in its factored form for right now. We'll talk about what to do with it when we get to some other examples where this LCM is actually used for something. So let's take a look at number 3. Now, all of a sudden, there's no algebra here again. I must be looking at a basic skill with you to remind you about things you already know, and also to teach you a way to write the numerical problem as an introduction to the way I want you to write the polynomials problem. So here's what I'm actually going to do. I'm going to take this problem and I'm going to rewrite it, leaving some space at the beginning and some space at the end. All right, I'm going to look at this problem and say, okay, what would be my least common multiple for my denominator? Well, my least common multiple is going to be 6, right? That's the smallest number that's evenly divisible by both 2 and 3. So notice I left some space after the second fraction, and then I wrote a big division bar, and under the division bar, I wrote what I know my common denominator is going to be. All right, so I look at that first fraction, 1/2. I'm like, okay, if the denominator needs to be multiplied by 3, then the numerator needs to be as well. So 3 times 1 is 3. And then I see I have a plus sign here. All right, my second fraction. If I want that denominator to become 6, I'm going to have to multiply it by 2, which means I also have to multiply the numerator by 2. So looking at my numerator, 2 times 2 is 4. So my final answer for this sum is going to be 7 over 6. And you're going, Mrs. Leonard, I could have done that in my head. I'm sure that you could. But it's the process of how to write it out that I want you to learn. Because when you do this with polynomials, you're really just not going to do it in your head. So you need a way to write it down. And this lets you see why the way of writing it down works, because you can see it with numbers. So let's look at number 4. Let's put all these pieces together. All right. The very first thing I want to do here is factor, and I'm going to factor right underneath the problem. Look at the denominator in the first problem. I can take out an x, leaving an x plus 3. My second denominator looks like a perfect square trinomial, actually. That looks like x plus 3 times x plus 3, right? X plus 3 squared will give that to me. My numerator can't be factored in either case. All right, so I've got to be thinking about the least common multiple. The least common multiple. So I'm going to start writing this out. I've got 4 over x times x plus 3. Notice I left some space to the left. Plus x minus 2 over x plus 3 times x plus 3. I'm going to leave some space, write an equal sign, and in my denominator I'm going to put that least common multiple. Notice they both have an x plus 3. So there's going to be an x plus 3 in my least common multiple. But notice this one has an extra x plus 3. And this one has an extra x. So there's my least common multiple. All right, the first fraction is missing that x plus 3, the extra one. My second fraction is missing an x. So my new numerator is going to have a 4 that's been distributed to x plus 3. So that's 4x plus 12. My second piece of my numerator will have an x that's been distributed to an x minus 2. So I'm adding an x squared and a negative 2x. So I want to see if I can simplify that numerator at all. So putting that in standard form, I've got x squared plus 2x plus 12 all over my least common denominator, or my LCM, here. Now, be careful. Always check and see, can you factor your new numerator? Sometimes you can. So we're going to look at that. What multiplies to make 12 and adds to make 2? Well, 12 can be 3 and 4. That doesn't add to make 2. It can be 6 and 2, which does not add to make 2. It can be 1 and 12, which does not add to make 2. There aren't any other factors of 12, and just changing those to double negatives, that won't make a 2. So this is my final answer. Now you're going to notice something. You are not required to multiply denominators in addition or subtraction problems. This is my little gift to you. I'm saving you a little bit of work. You have to multiply out your numerators. If it's a multiplication or a division problem, you have to multiply everything out, because the point is to see that you can do the multiplication. But the point of this problem is to see if you can make your least common multiples, that you know how to add and subtract, that you don't forget to distribute, etc., etc. So I don't care about you taking that extra step of multiplying the denominator through, so you don't have to waste your time. The one thing I would like to see you clean up is don't leave that as x plus 3 times x plus 3. Make it x plus 3 squared. It's more efficient. But I would consider that to be the end of the problem.